Hello students, in this video we are going to learn about electric potential at any general point due to a dipole, and this general point should be from center of a dipole. This is our question. So look at this diagram. Here is a dipole, AB is a point, minus Q plus Q is there, and here this is a direction of dipole moment which we know already. We have discussed all these details in our previous videos also. And here is the reference point P, that is at any general point we have taken, and from the center it makes an angle theta with respect to the dipole moment direction. You can see that. And here R vector, it shows the direction O to P. And R1 is the distance A to P we have written here. And BP is R to B to P with respect to plus charge. It is R2, and OP is nothing but the R distance given here. And we are going to discuss about the electric potential at this reference point P, which lies anywhere, that is any general point due to the dipole. The length of the dipole, as before we have taken, this is going to be 2D. From the center it is D and D. Total is 2D. This is a description of the diagram. We are going to discuss about the total potential V is equal to V1 plus V2. V1 is nothing but the electric potential at the point P due to minus Q, and V2 is the electric potential at the point P due to plus Q. Sum of these two will be the total potential due to this electric dipole AB. Therefore, we have to write the formula for the same. We are writing here potential is equal to 1 by 4 pi epsilon. And we are also writing, taking this common inside. Okay, therefore, minus Q we have written upon, what is the distance of P from here? This is R1. As we have written here, we can substitute the values. And this is due to, V2 is due to plus Q, and the distance is R2, as we have assumed before. This is the initial step of this. We can also proceed this, taking Q common outside, 4 pi epsilon 0. And we are taking here 1 by R2 minus 1 by R1 for the sign convenience. We have taken, let this be equation 1. Okay. Now, when we simplify this formula, we proceed to the derivation. V is equal to Q by 4 pi epsilon 0. And what we are going to do here, this is R1 minus R2 upon R1 into R2. This is a simplified formula now. Still we can also simplify, or we can leave it as such for one more discussion. What is that? Now you consider when this point P is far away from this, much away from this, when it is much away from the center of the dipole. We have to consider this point also. Look at this, it's very far. If we assume this, then we can take this line, okay, with respect to the cos angle, we can find the distance at small extent wherever it is possible. Therefore, we consider this is R1 and this is R2. So, by considering the equal distance from this, then the difference whatever is there, that is going to be R1 minus R2. Therefore, what do we consider? When this is very far, when point P lies far away from the dipole, then we simplify this. R1 minus R2 is going to be here. You can write what is in sign conventions. We can write approximately, we write. Okay, the length of the dipole. Therefore, we write AB is the dipole with respect to that cos theta. That is going to be 2D cos theta from the diagram. And also we can consider when this is much away from this, anyhow R1 is equal to R2 is equal to R. Therefore, R1 multiplied by R2, approximately that is also going to be R square, R into R. This is the assumption we have taken when P is far away from the center of the dipole. Therefore, we can simplify this equation number 2. Look at this equation number 2. We have R1 minus R2 and R1 into R2. Therefore, you substitute this Q by 4 pi epsilon 0. When you simplify it inside, substitute this as 2D cos theta and upon R square, which is there. Now, you can further simplify this, because we know that since the dipole moment which we have discussed in the previous concept also. In our chapter 1 also, we have been discussing about this dipole moment, where dipole moment is equal to Q multiplied by 2D. What? 2D, of course, the dipole moment, it takes the direction from negative charge to positive charge. So we have written this. So now we simplify this 1 by 4 pi epsilon 0, and we are simplifying this here P cos theta by r square. We can also write this in order to write in terms of position vector. We can also write this in further modified way. In this, we are writing this formula where 1 by 4 pi epsilon 0 and P. Here we can also write in terms of r vector, P vector, r vector upon, here we write r cube. And this can also be written here because we keep on modifying this formula. Look at this formula here. Still I am writing in terms of unit vector, and I still write this as r square. This can also be written in this way. Okay, because we know this r cap is equal to r vector by r. Therefore, it is simplified in this manner. What is this? This is nothing but the potential which is written in terms of 1 by 4 pi epsilon 0 P vector dipole moment and the position vector of the point which lies at any general point with respect to center of the dipole and upon the distance r square. This may be your final expression for this question. It's most expected question in board exam. Directly the derivation or in the form of numerical, you have to solve it. Okay, but one more important point you can understand in this. From this you can derive that the potential V, electric potential, it depends on very important point here. It depends on the angle theta, depends on the angle theta. Where is that angle theta? Between the point P, the location of point P, that you can say that r vector and the dipole moment. Depends on this angle. You can see that how we have substituted and simplified this further. Let this be equation number 3, the final expression which is there for this derivation. I hope you understood this. Electric potential at any general point due to a dipole from center of the dipole. This is the diagram, and here is the description as well as the final expression. Also, the conclusion is given. Let us also proceed to one more concept. What is that? In connection to this, where V, that is an electric potential due to system of charges. You can look at this diagram, and this is very, very important for solving numericals. So in the similar way, we can learn for electric field also, which I have explained in my videos for chapter 1. So here, see, there are different charges, say Q1, Q2, Q3, Q4 till Qn. Number of charges are placed, and you take any reference point here P, and we can calculate at the point P what is the total potential due to all these charges, these many charges, say till n number of charges, and they are located at the distance r1, r2, r3, r4, rn with respect to the reference point. So definitely we can write the formula, the total potential of the system, please remember, system having more than one charges. Therefore, we can write here V is equal to V1 plus V2 plus V3 plus V4, because 4 we have shown, and till Vn. And we can also write in all this, we can write the common points here, that is a term 1 by 4 pi epsilon 0 is going to be there. Am I right? And taking this outside the bracket, and we can write Q1 by R1. The distance of point P from 1, and for V2 we are writing, taken already the common term outside 1 by 4 pi epsilon 0. So inside the bracket we are writing only the terms which are different. Q2 is a charge located at a distance R2, and for V3, Q3 is a charge located at the distance R3. For the charge Q4 located at the distance R4, like this we can write Qn by Rn. This may be the expression for calculation of total potential in a system due to more than one charge, okay, or due to many charges. This is the formula. Still we can simplify this. How? We can also simplify in this manner. You can write here in the terms of I is equal to 1 to n. So we can write here 1 by 4 pi epsilon naught, and you can produce this sigma, I is equal to 1 to n, you can write in this order. Okay, this is Q I upon R I. Okay, this is the simplified formula for the calculation. This is very important for solving numericals. I hope you understood this concept very well. Thank you for watching.